Okay. Hey. So for week 22, we are going to talk about dividing polynomials. We've got to remember a few things with our exponents. I noticed we were having a hard time last week with this. So I'm going to remind you of a couple things. One, multiplying variable or letter, then we can add exponents if we are multiplying the bases, right? If we're multiplying the bases, we can add exponents if they're on the same letter. So first we have to do 16 times 12 and negative times negative. So that would be, so I'm going to do negative 16 times negative 12, which is 192, positive. Then x to the fifth and y to the third, they do not have the same letter, so there's nothing I can do with them except write them down. That's it. X to the fifth and y to the third. Now, if that had been a little bit different to begin with, if instead of x to the fifth, this is example 1, we'll call this example 2. If we had negative 16 x to the fifth times, I don't know, negative 12 x to the third. Now, the negative 16 and negative 12 is still the same, right? So we still have negative 16 times negative 12, which is still positive 192. But this time, because these are both the same letter, when we do x to the fifth times x cubed, we can actually add those exponents together. Because they're on the same letter, we can add those exponents together. So 5 plus 3 is 8. Now, if you're going, wait, why is that? Well, let's look at what these two things mean, right? X to the fifth means x times x times x times x times x. X cubed means pop in another 3 x's and multiply them all together. 3 more of these, right? So we have 5 of them plus 3 of them all being multiplied together. And that's what an exponent means, is how many of them are being multiplied together. So there's a quick review on multiplying the powers. So let's talk about that real quick. We're going to call this example 3. This says all of this stuff is supposed to get squared. Okay, so that means we want to do 6 squared, and we want to do x to the fifth squared, and we want to do y cubed squared. Okay, well, 6 times 6, not 6 times 2, 6 is 36. And let's think about what x to the fifth squared means. X to the fifth squared means take x to the fifth, 1, 2, 3, 4, 5, and multiply it by itself. So there's 5 of them, and then multiply another 5. 1, 2, 3, 4, 5. That's x to the fifth times x to the fifth. Now, how many x's are being multiplied there then? 10 of them. Okay, so if you'll notice, if you have the same base, but you're multiplying, or sorry, you're taking a power to a power, then you multiply the exponents. Okay, so as a quick reminder, if you are multiplying the bases, you add the exponents. If you're taking a power to a power, then you multiply the exponents. And so to finish this question out, y cubed squared means we're going to do 2 times 3, which is y to the 6. Now, that's a quick review of multiplying and raising powers to powers, because now we're going to start dividing. And the dividing is going to stay simple at first and then get more complicated, of course. And when we're dividing by one term, like we are in these two examples, it's not too bad. If there's only an x on top, well, okay, great. Well, let's think through first. What's 50 divided by 45? Well, we got to simplify the fraction if we can, right? Simplify the fraction if we can. So you can think, what do these both have in common? You can divide them both by 5, right? 50 divided by 5 is 10. 45 divided by 5 is 9. And then x cubed. And that's really all there is to that question. Um, if, we're going to call this example 1, okay? Now, if we had example 2, where it said 50x cubed divided by 45x, well, now we deal with the 50 and the 45 again, divide them both by 5. That's our common factor. But we also need to deal with these x cubes and this x. And remember, x cubed means x times x times x. And then we have x on the bottom. Now, anytime we have a factor above and below, they can cancel out, meaning they divide out to equal 1. So now we've got 10 times what's left. And then the 9. That x on the bottom canceled with the 1 on top. So there's no x's on the bottom this time. Now, I don't know if you realize this, but what we just did, if you look back at the exponents in the original question here, x cubed and x to the hidden ninja 1. 3 minus 1 is 2, right? X cubed divided by x is x to the 3 minus 1, which is just squared. I think I said cubed on accident a second ago. I meant squared. So the shortcut here is if you're dividing, and again, they have the same letter, then you'll get to subtract the exponents. Okay? Okay, so with that in mind, let's look at this example number 3. One way to do this might be, I mean, if you have a hard time finding the common factors, we could just list, I don't know, this is, 12 is 2 times 6, and then we have x times x and y times y. There's 5 of them. 1, 2, 3, 4, 5 divided by 2 times 9. That's one way to do it and see if it helps. There's 2 x's and 1, 2, 3 y's. Well, the 2's cancel out. Couple of these x's cancel to 1. Couple of these y's cancel to 1. But you know what? That's 6 and 9. They have another common factor. So that's really 2 times 3 and 3 times 3. And then I have, another one of these y's canceled out. My bad. Then I have 2 y's left. Right? So that is 2y squared over 3. Now, short version, what these both have in common, biggest factor is 6. Divide the top and bottom by 6. You get 2 and 3, right? X squared and x squared completely cancels out. 5 minus 3 is this 2 right there. Okay, so there's that quick reminder. And again, anytime that I'm going too fast and you want more videos and you're inside Delta Math, remember you can hit this help watch video anytime you want, and they'll give you another way to get some extra help. Now, here comes the doozy. Here, this last one, when we were dividing by one term, right? There was nothing being added or subtracted, so it was just a monomial that we were dividing by. Now we're going to kick it up a notch. And we're going to divide this whole term, this whole polynomial, 29x squared minus 9x minus 6. Woo, look at that bad mamma jamma. all of that divided by 3x plus 1. Okay, so this time we're going to kick it up a notch, and we're going to divide the whole thing instead of just by one term. We're going to divide it all by two terms, right? This is a binomial, and binomials multiply a little bit differently and they divide a little bit differently than a monomial, right? Two terms. Now, what we're about to do, you can do this with a trinomial, any polynomial of any size, but you don't need to do it if it's just a monomial, right? We need to do long division for binomials or higher. Later, I'll show you a shorter way that you can use sometimes, but not yet. Okay, so but first we're going to have to remember long division with plain old numbers. So let's think about that for a second. Okay, so first we're going to remember long division with numbers. It's been a while, right? Everybody started using calculators. So let's do 203 divided by 6. Okay. How many times does 6 go into 2? Well, 0, right? 2 is smaller, so we can't start with that, but we can start with 20. How many times does 6 go into 20? So what we're doing in our head right now, we're dividing 20 divided by 6, right? And 20 divided by 6, let's see, that's going to be 3 point something if you used a calculator. 3 point, I don't know, something blah, blah, blah. I don't really care about that part. I only care about this whole number. So that whole number goes on top. Now to figure out our remainder, we multiply what we just got times the number out front, which is 18. And that's what we subtract, right? So we do minus 18. And then we subtract and we get 2. Then we start over again. We drop it like it's hot and then start over. So now we're going to do divide again. 23 divided by 6. It's still 3 point something. And I don't care about the point something. I only care about that 3. So that 3 goes up here. And now we multiply so that we can figure out our remainder. 3 we just got times the 6 out front. And we subtract 18 again. This time it's 5. Now what we do with that 5, since there's nothing else to drop down over here on the right side, there's nothing over here, right? So since there's nothing over there, we have two options or a few different options on how we're going to write our final answer with that 5. One way, you could literally write R as in remainder and then 5, right? We've done that before, way back in the day in elementary school. But at some point, we quit doing that and we started writing it as a fraction, or we went into decimals. And for now, we're not going to worry about that. So what we could do, this remainder on top here, and then put it over the 6 so that our answer was 33 and 5/6. Okay, so that's a quick reminder of long division with just numbers. So now we're going to divide using long division. And the reason we have to use long division is because this time we're not dividing by just one term. This time we're dividing by a binomial or any other polynomial. Anything that has more than one term, we have to use something like long division. Okay. So because we're dividing by something bigger than just a monomial, we got to do a little bit more work. We're going to start by figuring out, okay, I'm taking this big old long thing and dividing it by 3x plus 1. So this big old long thing, instead of saying big old long thing, people who are more precise like to say stuff like this polynomial, right? And we're going to divide it by that 3x plus 1. And I'm going to use the old school division symbol that we used in elementary school. to do long division. Okay, now just like we did a minute ago, we had all this divide, multiply, subtract, divide. We're going to do the same idea here. So we're going to start with divide. But just like we did with the numbers, we didn't divide 203 by 6. We only divided the first little bit. So we're going to divide the first little bit, which is actually called the first term. And we're going to divide it by, instead of all of the 3x plus 1, we're just going to divide it by this 3x. First term divided by first term. And we're going to simplify that. 6 divided by 3 is 2. X cubed cancels out with one of these x's, so I still have x squared. Okay, now anytime you do the division piece, we're going to circle it and put it up on top. So I'm going to put that x squared above the x squared. You can put it wherever you want as long as it's on top, but it could be above the x, the 9x, or the 6, or the 6x cubed. It's just, I like to put it above the like terms. It helps me organize things and keep them straight. And so anytime you divide, then you are going to put the answer on top. Next, we are going to multiply the answer we just got, just like we did down at the bottom here. See how we did this down here? We did this little step here where we did what the answer we just got, 3 times the number we were dividing by. Same here. We're going to get the answer we just got, 2x squared, times, now this time we're going to do the whole binomial out here, 3x plus 1, and we're going to distribute that. So 2 times 3 is 6, x squared times x cubed. 2 times 1 is 2, and then x squared. Now the point of multiplying is to subtract. So now I'm going to remind myself to subtract. And sometimes keeping it straight, keeping all the signs straight, it helps just to write this out with the different, changing the signs. Then I can pop it under here. This is what I'm actually going to subtract. So minus 6x cubed and minus 2x squared. And then see what we get. Well, the x cubes cancel out, right? 6 of them minus 6 of them. 29 minus 2 x squared is 27 x squared. Awesome. Step 1. Now, just like we did down here, once we subtracted, we drop down the next one and then divide it, start it all over again. So that's what we're going to do. We're going to drop it like it's hot and then repeat the process. So I'm going to start with divide. 27x squared. I'm just going to do the first term though, remember. Divided by the first term. 27 divided by 3 is 9. X squared divided by x is x. When you divide, that part of your answer goes up top. That's the important part. Now we're going to multiply the answer we just got times the whole thing out front, 3x plus 1, the whole thing that we're dividing by, and distribute. (9x times negative 1 is negative 9x. And then subtract. Again, it's easier for most people if you remember to change the signs. So this minus 9x is going to be a plus 9x. So minus 27x squared plus 9x. Negative, or 27 minus 27 is gone. Negative 9 plus 9 is gone, so it's 0. And then I got to drop it like it's hot. So I guess I could put a 0 here, but it's not that important. Now I ran out of room a little bit, so sorry about that. I'm gonna have to do this really small. I'm gonna divide the first term, 0x divided by 3x. Now that's just 0. So what we've got here is we know that we're kind of done because when we multiply, the next step would be multiply everything by 0, right? Which would be 0. And then subtract. So we know that this is our remainder. Um, oh, and I guess I could put that 0 up here because I divided. Now, honestly, do you need to write plus 0 at the end? No, we don't need to write that. But we have to decide what to do with this remainder. And one option is literally write remain r -6, but the other option is we write minus 6 divided by what we were dividing by the whole time. And that, my friends, is your answer. And again, remember, anytime this is not enough information, you need more videos, inside Delta Math, you can hit help, watch a help video. Okay? All right. Good luck.